Hello and welcome back to another episode of Effective JaRu, the series where we will read effective Java and try to port all the items over to idiomatic Rust, if possible. So with item 22, it's a bit special because, well, favors static member classes over non-static. This is very interesting. Let's read the first paragraph together. A nested class is a class defined within another class. A nested class should exist only to serve its enclosing class. If a nested class would be useful in some other context, then it should be a top-level class. There are four kinds of nested classes: static member classes, non-static member classes, anonymous classes, and local classes. All but the first kind are known as inner classes. So, all but static member classes are known as inner classes. Okay. I think it's really about the static part that matters. This item tells you when to use which kind of nested class and why. The static member class is, well, that's the second paragraph technically, but let's read it just for the fun, because all the others are then kind of very different, right? A static member class is the simplest kind of a nested class. It is best thought of as an ordinary class that happens to be declared inside another class and has access to all of the enclosing class members, even those declared private. A static member class is a static member of its enclosing class and obeys the same accessibility rules as other static members. If it is declared private, it is accessible only within the enclosing class and so forth. So basically, it follows the same rules as static members. Basically, which should mean that it cannot access any instance methods or members. That would make sense. Which also means it does not have an implicit dis pointer to its enclosing class, and that's quite interesting. Because really, the only thing that was really new to me is that enclosing or nested classes, which are not non-static, they are able to actually access all data of their parent class, which means they need a pointer to their parent class, right? And they have that actually by the means of, there's a special name for this, of a fully qualified this pointer or something. And I would like to try that. Unfortunately, there is no code for this here, which is a bit lazy, I think, from the author, because there really should be, a simple example. So now I have to make it myself, which probably is a good thing, because that is kind of the first Java code I ever write in my life. I managed to create a new directory, which is a new package, add this information that it is a new package, create a public nesting top-level class that shall be for my testing purposes. And I would like, I call it nesting top-level, but I would like for it to be like foo. Why? Because foo provides an iterator that is specifically made to work with foo, but in Rust, obviously, you cannot nest type declarations at all. I think it's a good thing, but people might argue about that. To me, it's a good thing. I think it makes things very clear. So the implementation that I have here is like a mini state machine. It will just keep a borrow on a read-only, a shared foo it will keep, and will then just maintain its own state so that it knows what to output the next time it's called when it's consumed. The state is 2, not higher though. We don't want it to wrap around or something. And it will return none forever. This is what you see here. Quite easy. That's how this stuff works in Rust. No nesting going on. But of course, as both types are implemented in the same packet or in the same module, they can access each other's private fields. So this would especially be interesting if maybe I should provide a constructor here and should reduce access for these guys to be private, because right now I'm kind of using this to my advantage. I think I want this to be new. Let's make it 4.2. And then we throw this thing in here. Pop-fn new, which takes an A, use 16, a B, use 16, returns foo, And yeah, just some writing practice. But here we go. That's a new foo for us. And the test case should still work. Cargo test unit. There we go. Very nice. Thank you very much. So now the same thing here. So we have first public final class, because this is not designed for being extended. No inheritance, please. Then private. We use it like a final. Private final non-static. Well, short, right? Short would be the closest here. Kind of. Short A. Private final short B. And that's these guys. And now we have to go with the implementation. We have no... Yeah, I think it's okay to just have a constructor here that takes 2 arguments. Short. Yeah, I have to invert everything. Now I find it nicer if I find this order much nicer, basically. First the identifier name, then the type, the return value of the method or function last. Makes total sense. Also, especially in C++ template world, when you actually want to refer to something that is not yet declared, and you can't do it because of this syntactical issue. Anyway, so we have A, we have B, and I really have no idea. We'll have to compile this a lot to see how this works. So A is A, right? B is B, because this is an implicit dis A, or do I have to write that? Let's find out the hard way. No! Error, variable A might not have been initialized. Okay, so that is apparently not... That didn't work. So now... Okay, that finished. Good, so you have to provide this when you access fields. Is this what I should learn from that? Maybe. Good, so now we have a new here, basically. Then we want an iter. And to get this iter, we want to have a type that implements iterator. So the iterator interface, right? How do we do that? Java iterator interface. This is what we want, because then I think you can use it in, I think we have 7 here, but that should be the same. Has next. Oh, that sucks. Oh, because you have to do the has next thing because you don't have optionals. Yikes. Which is kind of a double check that is enforced on you, huh? Because you have to call has next, and next technically should check as well if there is a next, and then throw if something goes wrong. And this is unchecked. All of it is unchecked. So you may not throw an exception at all, or it's a runtime exception. Gee, I really dislike that. Not to say hate is a strong word, but I'm getting there. Maybe I'm getting it all wrong and it's all cool, but this looks to me like having to double check stuff. Throws. Oh, look, it does throw. No such element exception, which is throwable exception. It's a runtime exception again. Why is nothing checked here, man? I was thinking checked exception are a good thing, but no, they're not. So remove. Unsupported operation exception. So I guess this is something I don't have to implement, and I will try not to. All right. So I could use possibly, let's have an iter method here. So I public. Oh yeah, this guy must be public. Public nesting level. Now we want a public. Well, do we have to make it final? Probably not. Final, what does it mean? Nothing in this context. Can't be overridden, but we can't be overridden anyway. So it's public iterator. Yeah, where is it defined? How do I get that? Java util. Call me stupid. How do I import? So import is used here. Import Java util iterator. Yeah. like that, like that. I hope that, yeah, that's the raw type. Yeah, that's a term even. That's a raw type. So in order to be compatible, even stuff that is generic or can be generic supports this raw form, which is behaving like the old non-generic version. Yeah, generics come next during the next item, so let's not talk about it too much. So that's an iterator over short, but how do we do it now? We have to pack it, and we have to use autoboxing here, because iterators return. Can they return primitives? Let's try, because that's exactly what I would want to do, but probably that can't work because we are in Java world. So we return an iterator, and the function is called iter. That's it, huh? And now we could try to return an abstract. An anonymous instance. So return. Oh, yeah, I have to type return here. Return new iterator over short instantiated. So now we have the class body here. And let's see what it says. Yeah. Required reference found short. Unexpected type. Does not override the abstract method remove. Oh, that sucks. I have to implement remove, even though I don't support it at all. So there we go, that all the mutable stuff is all in one interface, and you can't kind of prevent that from happening. It's really all just mixed up and no fun. No safety goes with that either. Okay, so we have to rely on autoboxing here. At least that's what I want. I've seen that before. I think it's really easy. You don't have to do anything, basically. Just works automatically, which is also a problem because you might just not realize that you are boxing something which puts your value onto the heap as a copy, which is crazy. And also that wouldn't ever happen in Rust, something that just happens automatically, because Rust, for good reason, is very explicit. And I like it. I like it because the alternative is this. So let's try. We want a state. Private short state, and oh yeah, we have an implicit dis of the enclosing class. So that's good. Then we implement next. I don't know, do I have to make it public? Let's find out. This returns an E, right? So you can return short next. Feels so weird to write it. But hey, it's C++y in a way, but a bit more flexible, to be honest. So that's one of the cool things, that you can do inlining of anonymous types. I like that. In Rust, you can do that too. If you would do the same thing, like returning a boxed implementation of some interface, in that case trait, then you can totally, erase the type that was underneath and prevent an export of the implementation. Because as you can see here, I must make the iter pub because I return it directly. If I were to return a boxed version to an iterator trait, which basically does the type erasure that I was talking about, then I could of course get away by not exporting this, right? You can't do anything with that iterator really, but less implementation that is exported is better, right? So short next. Let's see. If do I have to do parentheses here? Probably. If state is 0, then state plus equals 1, and we return. Well, can I only access it like this? But that's the fully qualified way of doing it. But kind of makes sense. So my own this would be this. So this A. So else if state is 1, then state plus equals 1, and return nesting top level this B. Of course, not to forget state plus equals 1. And else there shall be return. Well, yeah, this shouldn't happen, right? We have to throw something. And we have to implement more because we have to do the has next thing. Ugh. Unless we are super... that is annoying. I don't want that. We could, of course, refactor and say, well, we have a private implementation function that doesn't change our own state, but returns what it has to return. And then if it doesn't throw up, we will increment our state accordingly. Otherwise, we will rethrow, possibly. But all that throwing, I think, is more expensive than doing the necessary work here. But in any way, I need to implement more. So what can I throw? Throw no such element exception. I probably have to import it, but maybe not. Let's try not to. Oh, Java util no such element exception. How can I import multiple things? Oh, I don't know. I don't know until I know. I'll do it like this. Throw one of these guys, and constructor can have a string, but I say fu here you go. This is a weird interface with the exceptions and stuff. So probably the for loop implementation doesn't call has next all the time, but instead, if that even works with an iterator, that is, we will see. But instead, maybe listens to or catches exceptions. That would be something, huh? Because then has next wouldn't have to be implemented. Okay, let's see to what extent this makes sense. Just one error, that's good. It's a syntax error though. Oh, we increment the state twice here. Yeah. All right, so what? Is not abstract and does not override abstract method remove. Okay. Cannot implement next in iterator. Attempting to assign weaker access privileges was public, where E is a type variable. What the? So, I think I know what it means. So that was my question. Do I have to make this public? Yes, you do. Okay, no such element exception, no likey. Error cannot find symbol. Really? But I imported it. What? Okay, so the remove thing is one thing, that's okay. But no such symbol method. So maybe I cannot make the call here. It wants to have a method. Maybe that's not how it's done. Now cannot find symbol. Yeah, what? With not here, that's a constructor. Constructs say no such element exceptions with null ethics error message string. Exactly. Could also make this explicit. Maybe I'm getting the syntax wrong. Is there something else to upload? No. So the syntax. Get, grab, throw. Show me where stuff is thrown. New. Oh man. Sure. Sorry, I didn't. Go is better in that regard. Go doesn't force you to new everything. It just does it if it has to. And you kind of know that this at least allows Go to put stuff onto the stack, which is totally valid, and move it elsewhere if it has to be moved elsewhere. So yeah, again, I think as a Java programmer, you will totally love Go, because you have all the disadvantages that you had previously, but even less disadvantages when you look at the code that you write. Okay, so that should now be working. Okay, cool. And now it's just the remove. And I don't know, has next? Is that auto implemented for me? Probably not, actually, because iterator is an interface, which means I have to implement everything. There might be an abstract iterator that... Is there an abstract iterator? Is there a search here? No. Why would there be a search? Wow, you really see that Java is old. Yeah, next class, all classes, sure thing. I want to look through this myself manually. And this might be why programming in Java is so expensive. I probably just want to keep this open and search for Java abstract iterator. Guava library. Yeah, so I guess no. Interesting. Really interesting. So here, this is how it's implemented. Has next get value. Ah, so that's the immutable abstract thing. Yeah, I don't know if I want to implement it that way. I would go all manual on it and say, well, public bool, boolean. Oh yeah, boolean. Why would you like a bool? Boolean has next. Well, state is larger than 0, 1, larger than 1. Right? Or wait, smaller than 2. So that's kind of what we want to test for. So we have next of our state is smaller than 2. That's nice. It's at least fast. But again, yeah, well, we have to check for this anyway. So people have to double check now or use exception handling here. Okay. Anyway, so that is that. Right now it should only tell me that I have to implement remove. Oh no, it hates the world. Yeah, sorry. Sorry, that was Rust speaking. And now it wants to have remove. Okay, how does that work? Just remove the element. Removes the underlying collections. What? Removes from the underlying collection the last element returned by this iterator. Oh. Called once per call to next. I see, that is interesting. So unsupported operation exception. Is there some sort of prelude so that I don't have to import everything all the time? Probably not. I'm not sure. Maybe let's try it, huh? Public void remove. Throw new unsupported operation exception. Oops. Wow, that worked. Okay, so we don't have to import that. That's good, but we do have to import this guy, huh? Yeah. Okay. That is very nice. So we just implemented a valid iterator in line. So that's kind of cool, even though, on the other hand, it's more difficult to read. It's more visual clutter. Huh? You have to process. Oh, that's a function definition. And in there we return a new anonymous implementation of a single interface. By the way, you can only implement a single interface here, not multiple ones or so. So this is kind of limited. If you need more, you need local classes or something and work with that. But okay, so far I'm happy to see that I was able to write a little bit of Java code here. And this is kind of the same thing that you have here, but in Java. And we use the fact that we have, for non-static nested classes, access to the enclosing class. Which is interesting, because we can, again, do any kind of mutation here. Nobody cares. And this is basically the downfall of Java, right? It's not Rust in the sense that it verifies that we don't have any weird data access going on. Also with threading, there's no help there. And. I'm really looking forward to learn about threading here in Rust and Java, and I have the feeling I will not like it unless you use channels exclusively for communication. So, good, let's try to use it. I think the easiest way that I've seen here all the time is if you add a main method, public static void main string args, because then you can create a foo, which is a nesting top level, and we have to new it, of course. Oh, and we have to specify everything. There's no let, there is just us and carpal tunnel. So let f be a new nesting top level. I'm asking myself, why do I have to new this? There's no reason to do this. And so you are in Java, get used to it. But it's inefficient. Get used to it, man. All right, this is what we have to do. Nesting top level. Oh yeah, constructor of 4.2, similar to the Rust code. And now let's see if we can iterate here for yeah, I've seen this. How does that work? I think it's like short field or member, and then like this, huh? F iter. Like that. So if that works with the auto thing, with the auto iteration, then we are good. System out. Let's see how that worked again. Good grab system out print line. Okay, that prints a string, I suppose, so we have to format this. Or printf, look, printf. Print line, printf. Yeah, maybe printf is good. Formatted print. Or maybe print line and then the item. We're already good. So does that make any sense? Nope. So, error. Constructor nesting top level class cannot be applied to given types. Really? Okay, let's look at... I'm certain I just get this wrong. So here we have a constructor. Do we create this somewhere? Probably have stuff like that everywhere. Example, so new phone number here. So here we have a construction of a new thing. And we throw it, we declare that like this. I've done that. So here you see that you need this to access fields. All right. But why does it not like my new here? And they do the same. It's the same situation. So actual argument int cannot be converted to short by method invocation conversion. Required short. And it got int. Shit. So there's no type inference at all. S? Maybe? Probably not. Nope, that's syntactic trouble. Okay, so I guess you have to convert it, huh? So it starts out as int, and we have to short it. Okay, and this is why people prefer int, because otherwise you have to do nasty stuff. Okay, good. So now it's just this one. For each not applicable to expression type. What? What does for each need? Required array or Java lang iterable? Oh, and we have an iterator. So why aren't we not iterable? Java lang iterator versus. Oh, there are two ones? Why are iterable and iterator different? Yeah. Java language iterator even is there a good reason for this? Is there merely an artifact of bad design? It seems strange since the only thing that an iterable is good for is providing an iterator. Ah, so that's the iter basically. I see. So we want to implement that as well. All right. So do you link to this? Good. So I get it. So in order to make this work, if you look at this, we call iter manually here. And if you want to iterate over it, which we don't explicitly do in the Rust code, if you do that, we basically want to provide an iterable here so that it can make the iter call itself to get the conversion. That should be really easy to do. So Java lang iterable. Here we go. Show me. And it returns an iterator T. We can do that. Iterator. Right? So implements iterable short. Yes. So probably it doesn't like it. Well. Oh yeah. So now I can actually provide this here and it should just work, huh? Oh my god, it actually did work. So yeah, awesome. I mean, we managed, right? I'm proud of myself. I was able to write Java code, so it's actually relatively easy to do it, as long as you got your mental model right. And yeah, I'm always afraid. I'm always seeing all the overhead there, which annoys the heck out of me. Also, it's cumbersome, obviously, because the compiler is so dumb. It's really just dumb. So in a way, you probably just want to go with ints all the time because, well, everything is inted and, it's a fake. It's a head fake. It seems easier that way, but you actually lose a lot. You lose at least one bit in many cases. And you don't really think about the domain of your types. You have silent wrapping, silent overflow. And yeah, well. I don't like that. Good, so what else? We could try to collect this into an array, but I have no idea what an array is. We are 33 minutes, 33 seconds in. I think that's okay for this example. I mean, I could, I think I got the idea. The main difference here is some naming stuff. So that's an anonymous type here. Then we have the static ones, we have the non-static ones that have always access to their enclosing class. Then we have the static ones that have access to their enclosing static members and methods. And that's pretty much it. And the rest is really just how you want to call this stuff. Yeah, so that's how I see it. And if you can have a static internal member, then make it static. Because you don't want it to be tied to some instance. Anyway, so I think the static stuff is a builder. Let's quickly, actually that's a good idea. Let's quickly apply the builder pattern here. So in Rust, yeah, in Rust, how would you do this? I mean, there are multiple ways to do this. Pubstruct builder. Just for the fun of it. Usually I have the tendency to just keep a foo internally, and then if there, and then use a private constructor to get it to get a foo and then initialize it later, or, you know, anyway, this has been done in a different item. But here I'd say, well, let's have inner. Let's have inner, which is a foo. And then we implement the builder and say pub fn a mat self and a, which is, I could call it v for value, which is a u16, returns a builder. It's always useful to just use yourself, which is your type, right? So at the end, oh, actually, no, not a mat self, but a mat self. We own ourselves, we consume ourselves and return ourselves in the process. So self inner a is v, and then we go for b, and the b is v, and then we go for fn build. I want to have a consuming one, and of course we have to create it, right? So pub fn new, which shall return a new self, which is a builder with inner foo new 0 0. We don't mind, we just have a default here, huh? You could actually implement default for the foo, but then the builder pattern would be kind of, you know, it's just for testing, kind of nested classes, right? Or class nesting that in Rust is never nested, obviously, but that you can still have. And yeah, it's kind of the silly version of it. We consume self, but return a foo, return self inner. So that's a one-off builder here, but you could also make it so that you can create multiple ones if foo had clone. But here we just consume, right? So that's cargo test for us. Cool. That actually works, even though we don't test the builder. So let's test it just real quick. So let f be a builder new, a is 4, b is 4, and then we have build, right? This is our f, and then once again, oh no, we have 4 4, but anyway, now we can just compare it like this and it should still work. It does. Yeah, cool. That's the builder pattern. Let's implement it here as a static. That's the idea behind that, because it doesn't need or can't have access to an enclosing instance, because that is what it wants to create, right? Obviously, again, with the access here, you would change a few things around. Maybe I then make it private. I wonder if this guy has access to a private one. We could change this right away. So we want to have a new builder that we just create using the constructor like this. Then A is this, and B is this, and then we say build. So that shall return a new top level thing. Then we can of course do the typical fun part. Let's move it around. And that looks shitty. This is why you don't do that. I don't know if there's if there's some sort of literal way to get a short here. For short, too short, haha. But no. Apparently, I mean, I don't know. Maybe there is a way. I might find out at some point. So there's the nesting top level. Now I will obviously not be able to build this. Let's see if we can get the public final static whatever builder going here. That is a static class public final static public final public, I don't know, static static public final what? Static public final class builder. What the heck, man? Really? Static public final class builder. And now we go in here. You have a public builder that does nothing, I think. Oh yeah, we want to have some sort of inner state, right? We need something. Yeah, so in this case, yeah, I would like to have an inner state. Why not? We could implement it private final. We assign it once, right? This has nothing to do with constness or something, or being immutable. Private final nesting top level inner, and this is what we define, this is what we set up here. This inner is new nesting top level. Now we access the private constructor. Oh, really? I think so. Short 0. Oh man, hatred. So here we set it up, and then we say public a, which returns, oh no, wait, we return a builder all the time, so return this, and we have to explicitly do that, obviously. Then we have this, oh shit. You know what? Let's make this an int, just to make it a bit better for us. Int v, so that's the value. This inner a is v, and then it's done. And then builder b, and this should work. Oh no, we need a build. Public builder, and now we go unsafe. So wait, public nesting top level build, because now we consume ourselves but can't tell, right? The only thing we can do to protect ourselves is to check for null here. If this inner is null, raise some assertion error, throw new assertion, exception, I don't know. Cannot return the same thing. You know, we don't have consumption here. We can't do it. Either we protect ourselves or we do it differently. We could clone this thing. We could build it freshly. Right now we kind of do it in a way that we can't really support in Java. Doesn't work that way. It's easy for us in Rust because of the stronger semantics, but not here. Not here. Yeah, well, let's do it like that. This inner is null, and then, oh shit, nesting top level res, that's just temp, right, is this inner, then return temp. Oh my god, this feels so awkward, really. So honestly, I think Java is way less efficient in programming it than Rust, and Rust is much safer while you do it. I mean, I would have no reason at all to use Java. Oh, good. So here's the nesting top level. Let's see if you can build it. Nope. This. Oh yeah, shit. Syntax error. See, this happens. Enforce parentheses for no reason. And you ask yourself why. Oh yeah, there is still a syntax error. Cannot assign a value to a final variable. Oh, okay. Private, like this. again. Cannot assign a value to final variable a. Possible loss of precision. Ah, now I get it. This is final here, and I didn't know. But this, again, this can be final because we assign it only once. Oh no, wait. Here we want to set it 0, so that would indeed not work. So yeah. Again, possible loss of precision. Yeah. At least it checks that. That's a good thing. It's much appreciated. In Rust, you wouldn't compile it because it's different types. So you have to convert it. So we do the same thing. By the way, because we now have it as int, we can do that. There must be a way to have a short literal, huh? There must be a way. Java short literal. What is it? Yeah, exactly. This is suffix. This is what in Java interliterals have R-type ins unless they're suffixed with the letter L or I. Capital L is preferred as a lowercase L is hard to distinguish. Suffix with L, the literals are of type long. So where's short? Short. Short. What? There's no short? Oh man, this is an oversight. Come on, this is just missing. This is a partial API. If I can specify that I want to have a long, I must be able to specify that I want to have a short literal as well. Oh, damn it. This is a... Honestly, this is a joke. This is really bad. Oh, it will be very, very difficult to shut up about this when I actually have to program real software with that. Probably I just have to learn to cope with it. Yeah, so back to business here. Let's convert it. Cannot find symbol. Assertion Java throw assertion error. So how do you do it? Excuse me, hello. What the heck is going on? Ah, what the heck? Am I offline or something? Is something weird happening right now? Google is down. Oh my god. Java throw assertion error. Yeah? Yeah? So how can I throw it? Ah, it's called assertion error, not assertion exception. All right. So no such element exception, but assertion errors. Okay. I'm good with that. Cool, that actually built. And there we go. So that's about inner classes, right? And this also means that I should not be able to do stuff like this. Oh yeah, I don't actually want to. Foo is, so now we go with the enclosing type. We don't have that, right? Good. Non-static variable this cannot be referenced from a static context. Thank you very much. That was all I wanted to see. And that's our beautiful implementation of a builder that is nested and static. We learned why we do it with static and not. Make everything final, reduce accessibility, and yeah, whatever. Here we have a builder pattern built in. All right. And the same thing in Rust. Interestingly, Rust is less, of course, less to type and less clutter. There is some visual noise going on because of all the characters and stuff, but it's less to parse through than the visual noise generated by Java. So that's an interesting fact. Also, the interface is much easier. I mean, an iterator here is just an iterator, whereas the iterator interface here is a blatant mess, which is more complex than it has to be. I don't know. I really don't like it at all. But this is kind of nice, you know, once you have it, it works with the standard iteration. That's nice, but that's all about it. So that's really a mixed bag here. But anyway, it's a good comparison. We have made our first own item. Thanks for watching and have a great day.